Okay, let's move to Silvestro. Do you think you can share your screen and maybe you can just open the floor?
Can you see and hear me?
Yes, you're perfect. Yeah, you hear you very well, and then see your screen. Please go ahead.
Very good. Thanks a lot, Fumia, Josie, and everybody for inviting me, and thanks, Cecilia, for introducing the session. As Cecilia said, I will put in my presentation the human being, the person, and the person with disability in particular. At the center, what we try to work on in my lab is to translate basic science, and in particular neuroscience, to clinical applications, to help people with different kinds of disabilities to restore sensory motor cognitive function. With the idea, maybe it will be for the next conference, to use what we call the Lego bricks approach, to recycling technology to speed up the technology transfer and the translation. In particular, what I'm going to focus on today is how to design embodied artificial ends, embodied in particular artificial limbs in general, and how to do this in a way which could increase the amount of information we can provide to the person and increase then the real efficacy, of this kind of devices. In particular, what I will try to push for is the idea of what with Tamar Makin and Frédéric de Vignemont we call soft embodiment. So try to take inspiration from nature, but also in a flexible way, in a soft way, if you want. So Cecilia is one of the pioneers of the soft robotics. This is a softness with a different meaning, more related to, and you're going to see in a few minutes, how we connect artificial systems with the body in a way which is able to exploit existing neural resources, even in a slightly not standard bio-inspired way. And the example classically is, of course, we don't fly like Leonardo was thinking about, and the prosthesis for running, it's really not similar to the natural feet, but is more taking the inspiration from the principle, the mechanical principle of running. And here it is, more or less, both things are not exclusive. You can go for hard embodiment, taking really the neural resources where they are for the specific function. You're going to see in 1 second a specific application. But at the same time, again, you can be flexible, trying to find more original ways to do that. Just one example. At the beginning, I show you Luke Skywalker. What we tried to do in the past 20 years is to restore, for people with hand amputation, the possibility to have sensory information back. And in particular, the main topic we've been working on for many years is to find the good interface to be implanted into the peripheral nerve, close to the amputation level, to recreate this natural connection. And there are many different options, of course, available. I cannot enter into the details. You have different interfaces with more or less invasiveness. They damage more or less the nerve, and more or less selectivity, the ability to create an intimate connection with part of the nervous system. Something like suddenly I'm able to talk only with Fumia and nobody else can hear me. And after many years going back and forth with Thomas Stiglitz, Javier Navarro, and many other people, Ken Yoshida in the field, we developed what is called time electrode, which is a simple needle entering transversally into the nerve, leaving inside the yellow part, which is in this case polyimide, with the active site, which are metal active contact on it. So it's a very simple procedure. And exactly 10 years ago, we tried with Paolo Rossini in Rome with a patient. Here you can see, I hope blood is not disturbing you too much. But the procedure is pretty simple. We implanted for 4 weeks at that time our first patient, Dennis, and we asked him after a couple of days after the surgery, can you feel something? And here below, you can see the answer. Even if the hand is no more there, we can embody it in some way and make embodied the phantom hand of Dennis, and Dennis can feel at the phantom hand different sensation according to the active site, to where we are stimulating in the nerve. Then the next step was, is it possible to incorporate this information into a real sensory motor closed loop control? And this is what we did. Dennis did a remarkable amount of tasks. We published it 10 years ago, and then the follow-up with more patients a few years after. And the message is, it is possible. Dennis can quickly use this information, which can then we translate into stimulation of the nerve. And this translation from the sensors of the prosthesis into sensors of the nerve can allow him to control in different ways the prosthesis, modulating the force, understanding the compliance of the object, the shape of the object, and so on. So touch in some way with direct peripheral stimulation can be restored. But then the question is, can we do more? Proprioception is not possible to be restored by direct stimulation, and there soft embodiment can make sense, because what we did with Alberto and Eduardo at that time was to take another channel, which was mainly for paresthesia, so not really useful, and we made a sensory remapping, teaching very briefly the patient that the stimulation was the opening and closing of the hand. And the results were really amazing. The patient was able to get and incorporate also this information together with the hard embodied tactile information. So soft embodiment, finding in some way the way to hack neural resources for different applications could be used for proprioception. And recently, we also published a paper in Science showing that another soft embodiment, it is possible for temperature. Temperature, for physiological reasons, is even more difficult to restore with nerve stimulation. But what we found with Soleiman and Francesco is that putting on the stump and thermal stimulation, the subject can get again phantom, in this case, thermal sensation. So clearly, the message here is you can be flexible and use hard embodiment when necessary, and tricks, if you want, soft embodiment together. And this is what we are going to do using a skin provided by Benjamin T in Singapore, which is kind of similar to what the plenary speaker presented before, together with Johannes and of IIT. The idea is to have, for the first time, a prosthesis embedding all this kind of information between hard and soft embodiment. And then in a few minutes, what I want to show you is another application which intrinsically required soft embodiment, which is the possibility to control extra supernumerary arm, a third arm, like another octopus. Cecilia loves the real ones, but also the artificial one, Doc Ock, who is a villain in Spider-Man, is also interesting. So the idea is it is possible to control a third arm together with the other two. And in this case, the message is it is possible if you think about hacking other neural resources in what we call neural resource allocation problem to take what is called motor or sensory null space. So a space which is not part of the control, sensory motor control of the natural hands, but something related but usable. And for example, few months ago, we published in Science Robotics, here you can see the video, the possibility to use respiration and gaze to control 3 arms simultaneously. So hacking another kind of sensory information, not strictly motor information, not strictly the one related to the control of the 2 arms, which will be limited by this choice. So it is possible to control in virtual reality and also with real robot. Sorry, the real robot is not working, but you can trust me, the possibility to control a third arm, again, with soft embodiment. So it was not much time, but in conclusion, what I try to convince you about is that soft embodiment could be a good solution, both for artificial limbs in case of amputation or for supernumerary arm control. The idea is to take advantage of existing neural interfaces which are not necessarily the one we should look at to increase the repertoire of possibilities we have in the sensory motor control of different kind of artificial limbs. And of course, thanks a lot for your attention.
Okay, fantastic, Silvestro. I think this was really, really interesting, inspiring talk. And especially I like this notion of soft embodiment. I think this is really, really heart of what embodiment is. Yes. Excellent. So hopefully you can stay for discussion afterwards. And I'm sure there's going to be lots of questions also in the from the audience. Thank you very much.